the End of Unit Assessment Study Guide for Volume of Solids. I hope that this video can help out if you're having some trouble, if you're studying for your tests, or if you're going over your study guide. I know many people have been absent, so I hope this will be useful to you. When we take a look at the first question, it's really important. What I've noticed is if you try to jump right to the question without reading the front matter, you're really going to get yourself confused. So where it says circle all expressions that represent the volume of this rectangular prism in cubic units, what that means is that there will be more than one answer. That's what they're saying to you. Anytime you see circle all or choose all of something, there's more than one right answer. Okay? And then be ready to discuss why you chose each one. I'll try to involve some of our class discussion from today to let you know how we discussed each one of these. So, we have 5 different expressions, and we're looking at them to see would they fit to solve what the volume of this is. You're not being asked to give the volume. Knowing the volume will be really helpful for your solving, but you're not being asked to give the volume. You're being asked which expressions could lead us to the volume. So let's take a look at the prism itself, and some numbers might be helpful to you. So, as we take a look at the prism, you'll see that this face is 4 across. So we could consider that a length of one of the sides. I'm going to put a 4 down there just to help me out. Might be helpful, might not be helpful. Another thing that I might want to know is how deep this prism goes. What is the width of that rectangular prism? So as you can see over here, there's 3 cubes. So I'm going to put a 3 over here. Might help me out. The other thing I might need to know when we're dealing with volume, if I know length and I know width, the height is that essential element that makes it different from area. So this particular prism, if we're looking at it in this direction, is 3 high. The length of this side is 3. Okay? So, as we take a look at each one of these, we want to ask ourselves, is there some way that these numbers are related to each other so that they could be combined in some way in order to get the volume of this particular prism? So let's look at A. We have what we like to call cheeks. We have in parentheses the number 3 times 3, or the expression 3 times 3. Then we have that whole thing multiplied by 4. So the first thing you want to ask yourself, and sometimes I grab a highlighter for this, is where on the prism would 3 times 3 be represented? Can it be represented at all? So in class, we had people say, yeah, right here, there is a layer that is 3 across and 3 down, or 3 length, 3 width, however you want to call it. So I like to use a highlighter. Some people just like to try to circle that layer, but I think a highlighter seems to do a better job or shading it in. So the 3 times 3 is represented by this layer. Okay? That could be considered the base. Now, how many of those layers are there? 1, 2, 3, 4. There are 4 of those layers. So this, if we would turn this could be the base or the bottom, and it could be 4 layers high. Base times height. Okay? So the point of a question like this is to see if you can see the many different ways that you can look at a rectangular prism, that even if it's rotated, you can still get an answer. So then, one of the things I did was clear this off because I wanted to be able to look at the next one. If you can't clear it off, if it's a test or a quiz or something, you could always trace or redraw it to try to like sketch it out to see if you can work it through that way on another diagram. So B, all of a sudden there's addition, and you're like, why is there addition here? That shouldn't be right because they're plus signs. Don't be so fast about that, because what they're doing is they're repeating 12. So the question is, where do you see 12? There's a couple different places you can see a layer of 12. Okay, I'm going to go ahead and show you one of the things I saw that was 12 cubes. Oops. I might want to do that better. Doesn't always work out when I want it to. This face right here was one that I saw. Someone else in class saw that not only is this layer 12, but also this layer right here could be 12 as 2. Either way, you're going to get the same idea, even if you choose this top layer. So, if this is 12, then the question is, how many layers are there? Well, 1 layer of 12, 2 layers of 12, 3 layers of 12. Also known as 12 plus 12 plus 12. Okay, that straightened it out automatically. Sorry about that. So, if I keep my colors the same, I've got this 12, I've got this 12, and I've got this 12. So A and B both can represent that problem, or that volume of that rectangular prism. Now, as we look at C, you might be like, well, there's 9. And up here, 3 times 3, there was a 9. Okay, so I can get a 9 out of it. But then you have to ask, what are you doing to the other factors? Well, this says 9 times 9 times 9 times 9. Somebody in class said, well, I know that the other ones are 36. They were doing this in their head. They're like, 12 plus 12 plus 12, so that's 36. 3 times 3 is 9, times 4 is 36. So then you ask yourself, you look at it and you say, well, 9 times 9 is already 81. That can't possibly be one of our choices. So, if it helps you out, to cross it out, cross it out. Now, we also talked about D as being a cousin of one of these, and that was A. If you look at A, it says 3 times 3, 9, and then it has the 4 down here, 4. Okay? Question is, where does 9 come from? Well, you go back to that whole idea of this part being the base and 4 being the height, and there you have your 9 times 4. For E, we had to ask ourselves, where does 4 times 3 come from? And we talked about, well, this is a cousin for letter B. How is it a cousin? Well, 4, right here, get my colors. 4 times 3 is right here, right? That's 12, okay? How many layers of this are there? There's 1. There's 2, and there's 3. Okay? So you got your 4 times 3, then you have 3 layers of that, which ends up equaling, again, 4 times 3 is 12, times 3 is 36. So when you look at this one, the expressions that you should have circled are A, B, D, and E. And on your test, you'll have one just like this, but it'll be a different figure. I want you to use the same logic for it, though. Look at the figure, really think it through, okay? How is it that I could possibly get the volume of this? And I think you'll do okay if you slow down and read the directions on this one.